We are going to be looking at a couple of problems from section 5.3. This is using logarithms and exponential functions to solve equations. And these are both involving logarithms. And the first one is to use the change of base theorem to base formula to evaluate the expression log base 7 of 215. Let me get started by getting my pointer set up, and I need to choose an ink color. And now using my pen, I can do this. Now the change of base theorem says that what I have here, I can take this and I can rewrite this. This is going to be the same. And the change of base theorem involves a quotient. And in the numerator we can use either log base 10 or log base e. It makes no difference as long as we're consistent. And our change of base theorem said that this is going to be equal to the following. And now we need to use our calculator. So if I can get my calculator up and running, I'll make this a little bit bigger. Oh, shucks. Here it is. Making the calculator a little bit bigger, moving this up, I can make it even a little bit bigger. And so using the calculator, once I turn it on, I can clear out what's in here and clear everything out. So what I'm going to put in my calculator is the logarithm of the 215. Make sure you close the numerator, divided by the logarithm of 7. And the answer we get is 2.760. And so this is accurate then to 3 decimal places. I have 2.760. And make sure you see the decimal point there. Now just to demonstrate, I could have used natural logarithm just as well. So if I take the natural logarithm of 215 divided by the natural logarithm of the 7, we would get the exact same answer. Problem number 28 is going to be a bit more challenging for us, and so on problem number 28 we're asked to solve this logarithmic equation. What we want to do first of all is we want to get the log expressions on one side, the non-log expressions on the other side. And so doing that, what I'm going to do is the following. I'm going to subtract the ln of 3x from both sides, and I'm going to subtract 8 from both sides. And I'm going to run out of space in just a hurry, so I'm going to have to be kind of condensed on this. So I'm going to have 3 ln of x, and then I'm going to subtract off the natural logarithm of the 3x, and then on the other side I'm going to have the 12.18, and I'm subtracting off the 8, and I'm just going to write down what that's equal to. That's equal to 4.18. I missed the 1. Hopefully you can read that. On the left-hand side here, using the power rule, this 3 becomes then an x cubed. And so this is the following. I'll do this in a couple of steps so that hopefully you can follow everything I'm doing. This is going to be the natural logarithm of x cubed. I still have minus the natural logarithm of the 3x. And that's still equal to the 4.18. Missed the 1 again. Let me write that again, 4.18. Now, using the quotient rule for logarithms, I can rewrite this then as the natural logarithm of the quantity x cubed divided by 3x. And that's still equal to 4.18. How come I keep missing that 1? Now, the next thing we want to do here is we want to undo the ln function here. And so I'm going to use the e to the whatever function. And so I'm going to have e raised to the natural logarithm of this expression. And if I can just squeeze this in here, that's x cubed divided by 3x. And that's still equal to, this is going to be e to the 4.18. Now, on the left-hand side, the whole reason we do that is that undoes it. And so this e to the ln of x cubed divided by 3x is just going to give us the following. Let me put a line down here, and I'm going to rewrite that over here. So I'm going to have, I don't have any of that stuff. I just have x cubed divided by the 3x equals e raised to the 4.18. Now notice I haven't done any computations yet. Now here the x and the x cubed are going to cancel, so it's just going to give me x squared over 3. And let me multiply. I don't want to do too much. I might lose somebody here. So this is what I was trying to do. Let me see if I can erase some of the. I'll just keep going. Okay. When I look at this, this is going to give me not x cubed but x squared divided by 3 is equal to the e to the 4.18. Now again, I'm sort of running out of room here. If I miswrote this the second time, that's supposed to be a squared. That cancel. The x and the x cubed cancel to an x squared. Now if I multiply both sides by 3, looking over here, almost out of room here, but I'm going to have x squared is equal to then 3, and then this is going to be times e raised to the 4.18. And so then my x is going to be the square root of that. So let me write that up here, what I'm trying to say. What I'm going to have, I'm up here since I'm out of room down here. This is going to be then the square root of this expression that I had down below. This is going to be 3 times e raised to the 4.18. Now let's put this in the calculator. Turning the calculator on and clearing out the stuff we had before, I'm going to do second function square root, and then we have 3 second function e raised to the 4.18. Let me close the exponential function, close the square root function, and press enter. And my answer for this is going to be approximately 14. And this completes this exercise.